Okay, so let's think about what happens as this program executes. So we're going to start by drawing our stack over here, and we'll draw the stack growing upwards. Um, so the first function that's called is main. We only really care about tracking the local variables and the parameters here because those are the things that could be objects here. So there would be a dynamic link and a static link and a return address and all that stuff. That would all be on the stack. But for this week, we only really care about the things that we need to create class instance records for. And for main, that's really just the three local variables. So there's going to be three entries inside of main's stack frame. So I'm going to draw it like this. So we've got three entries here. This is all main. And then we've got, we've got Bonnie, which is a instance of class dog. We've got Garfield, an instance of cat. And then we've got Trogdor, which is obviously an instance of class evil. These are all going to be pointers because the objects are being allocated on the heap, as you can see up here. So the new keyword allocates an object on the heap. So we allocate Bonnie, which I happen to know is the name of Dr. Bauer's dog. So this is going to be a pointer to a region on the heap that has been allocated for a dog. So we need to think about what we need for a dog. So let's go and look at the implementation over here. So it inherits from animal, so there should be a Boolean called sleeping that is initially set to false. And then there is basically nothing else because dog doesn't add any member variables. So basically what we're going to have here is we're going to have two things. We are going to have that Boolean, so the sleeping, which is a Boolean, and that's going to start off as false. And then we're also going to have our virtual method table, which I'm not going to label, well, we'll label it vtable. And so because Bonnie is an instance of class dog, this is going to be a pointer to the dog virtual method table. And so this is just going to be a pointer to this class instance record on the heap. Okay, so now hopefully you can sort of see that you can follow the chain all the way through, but let's finish drawing the diagram before we fully answer the question. So we've also got Garfield, which is a cat. So we'll notice that a cat has another instance variable called lol power. So let's draw the class instance record for Garfield. So this is going to have three things in it. So we'll want to draw it a little bigger. So it's going to have the virtual table pointer. It's going to have sleeping, which again is a Boolean. That begins with false, just like it did for the dog. And then the lol power, which is initialized to 100,000. And that's an int. All right, and because Garfield is a cat, the virtual method table pointer is going to point to the virtual method table for cat. All right, so then all that remains is to do the table for Trogdor, which again is a cat, and because evil doesn't actually add any new instance variables, the class instance record is going to be the same size. So we're going to have our virtual table pointer, which of course, because this is an evil, is going to point to evil. Notice that it still points to evil, even though Trogdor's type in the function, and so actually I suppose down here we really should have Really, this really shouldn't be evil here. This really should be cat, because at this point, um, we declare it to be an instance of type evil, but then we store the reference in a variable of type cat. But because it is under the hood an instance of type evil, that's where the virtual method table points. And that's how we know to invoke the evil methods rather than the cat methods. All right, so then let's just finish this up. So it also has sleeping bool, and I believe it gets initialized to the same thing. And then the same, does it have a different low power? No. All right, and then of course we need to connect this here. Okay, so that's a little messy, but that is the complete setup for this. That is the full memory diagram.